Okay, hi, I'm Sarah. I'm a first year in the linguistics department, and I work with Jeff Hines and Jordan Codner. And a really important task in the work that I do is the task of morphological inflection, which is where we take some kind of base form of a word, which we call the lemma, some kind of features that we want to see that word in, and then we return the form of that word that realizes those features. So for example, if we want to see walk in the past tense in English, we know that that's walked. And this is an important task both in natural language processing with downstream applications to things like machine translation, as well as in cognitive science, where we're really interested in the problem of how children learn how to do this in their native language. However, state-of-the-art systems have reported very variable results across the literature, and we hypothesize that this is because their evaluation practices basically aren't as good as they could be. Specifically, how they split train and test sets in their data leaves a lot to be desired from a linguistic perspective, and that's what we're going to look at today. So we propose new data sampling and evaluation strategies to improve the generalizability and reliability of these models, and also to elucidate where these sources of variability are coming from. We look at three main practices that are currently done in the literature, and we propose changes to those practices. So with regards to sampling, right now, sampling of the data is done uniformly and unweighted. So we just put all of the tokens of the words in a bag, draw them out uniformly at random. But we know that language follows really skewed frequency distributions, so that might not be the best thing to do. We might want to sample taking frequency into account. And we might also want to explore, well, what happens when we've seen maybe just the lemma or just the features, but we haven't seen the other part of this triple. And that's currently also not looked at too much in the literature. Also, usually there's one single data split in the literature. And if you're familiar with machine learning, kind of in any context, you know that that's not great practice. So we propose that we should do multiple splits as well. And finally, we propose that we should control for overlap. So with regards to have we seen the base form of the word before? Have we seen the features before? Have we seen both before? And this summarizes our results over a number of different languages and a number of different neural models, but the results are quantitatively similar when we look specifically at each language and each model as well. So when the features have been seen, we see that there's not a lot of difference in performance, whether the lemma has been seen or the lemma is out of vocabulary. But when the features haven't been seen, we take this massive hit in performance. So we go from around 75% to around 25%. So it seems like features really, really, really matter for this. And then we take another kind of additional hit when we also haven't seen the lemma. And then we also see that when we don't sample uniformly, we take some hits as well here. So to summarize kind of what we should be taking away from this table, individual lemma and feature overlaps strongly drive the performance of these models, and prior reported results probably vary because they didn't control for these overlaps. So future evaluation should carefully control for linguistically relevant and informative overlaps in train test splits. Yeah, so because we're looking only at kind of like the data that we're evaluating on, it's very easy to get these models and just like rerun them on the data, which is how we got a lot of these numbers. So we're using models that were like put out in the last few years, and that's something that we want to look more into because we've only looked at a few so far. Yeah.
He was basically telling you like,
I would say similarly. Yeah. Yeah. Yeah, Jeff. Yeah. Yeah, so I think with regards to what kids are doing, which is kind of my main area of interest, we're looking here at a lot of neural models, which tend to be used more for NLP applications, and people do make cognitive claims about them. But you can kind of think about like, well, how much do these issues matter for NLP versus how much do they matter for cognitive models? And I think that drives a lot what you want the performance of your model to be. And you can easily have something for NLP that gets you what you want for NLP. And maybe having these issues is okay for NLP because you'll have larger training data, but it's not okay for acquisition because you know you have smaller training data. And so I think looking at other model models like in model architectures, especially for the acquisition, the cognitive modeling problem is definitely where we should go next. Yeah. Yeah, Owen. Mhm. Well, it depends on the type of morphology, right? Because if you have agglutinative morphology, so agglutinative is where you kind of glue all the morphemes on together. So maybe you have seen like the past tense third singular and you've seen the present tense second singular, then you should be able to get the past tense second singular because you have those two parts and you should be able to put them together. Well, for these models, not well, but we look at, oh, yeah. Well, we have Turkish, we have Spanish, we have Swahili. All of those languages have that pattern. And when we evaluate these models on them, they do absolutely terribly. Yeah.